Hi, Assalamualaikum warahmatullahi wabarakatuh. And today we are going to teach all of you about limits and continuity in subtopic 1.1 limits. So what do you guys think about limits? Actually, from the limit, we can find the tangent line problem and also the area problem. First, we got the tangent line problem. Okay, given a function f and a point x naught, y naught. On its graph, find an equation of the line that is tangent to the graph at P. For example, like here, you can see that in the picture, for the blue line is actually the is actually the for line P, and the red line is actually the tangent at P. Meanwhile, in this picture, we get discovered about the area problem. For example, here, given a function f, find the area between the graph of f and interval open bracket a, b, close bracket on the x-axis. For the example, like you can see here, the blue line is actually the function is that is y is equals to fx. So we need to find the area between the blue line. So a then b, and so a then b, the distance between a then b, we can get the solution by solving the by solving use limit. And now let us see what is actually tangent line. Okay, for tangent line is actually a line meets the circle or a point precisely at one point. So, for example, like here, you can see the red line meets the blue line at one point. For A, B, and C, that I circle using the red marker. What about second line? Second line is actually the line through P, and Q is called second line for the curve at P. And you can see more clearly at the beside of the centers, uh, there is a picture about the second line. When we move to the point Q, along the toward P, then the second line will rotate to the limiting position. That is what we call the limiting position is what we call or consider to the tangent line at P. And now let's move to the solving problem question that given in the picture. Like you can see, fx is equals to x squared minus x plus 1, and beside the sentence there's a lim x approaches to x squared minus x plus 1 is equals to 3. So now, as you can see, the function of x is equals to x squared minus x plus 1 behave as follows when x approaches 2. And you can see there is a red pen marker that say x arrow 2. That means x approaches 2. So we can say from the left, value smaller than 2. Fx gets closer to 3. Meanwhile, from the right, value larger than 2. Fx also approaches to 3. It is mean that the left hand limit and right hand limit are equal. Therefore, lim fx x approaches to is equals to 3. And this conclusion is supported both numerically, table of value from the table as you can see below the explanation, and graphically curve approaching fx as x approaches 2. As you can see from beside the explanation, there's also a graph and also a table that prove when x approaches 2 is equals to 3.
thinks of limit as a way to understand how functions behave as we get closer to a certain point. It's like peeking around the corner to see what's coming up ahead. An informal view of limits. So, what is exactly a limit? Imagine you have a function and you want to know what value it approaches as you get really close to a specific point. Say limit help us understand the behavior of function as we approach a specific point. If the value of f(x) can be made as close as we like to L, by taking value of x sufficiently close to a but not equal to a, we will write as below. Next, how to read the limit. The expression is read as the limit of f(x) as x approach a is L. Equivalently, f(x) approach L as x approach a. Now, let's delve into one-sided limit, which helps us understand the behavior of function from specific direction. One-sided limit. Consider what happens when x approach a from one side only. The limit of f(x) as x approach a is L. Equivalently, f(x) approach L as x approach a, as shown as below. Next, for the relationship between one-sided limit and two-sided limit. For a two-sided limit to exist at point A, both one-sided limits must exist and be equal. For example, the limit of f(x) as x approach to A positive is equal to L and then equal to limit of f(x) as x approach to A negative. Okay, next let's move to the question. Let's check if the two-sided limit exists for this function at x equals to 1. f(x) equal to x power of 2 minus 1 divided by x minus of 1. Now the solution for the question. Firstly, simplify the equation. Make sure x is not equal to 1. Now evaluate. From either side approaching x equal to 1, f(1) equals to 2. Since both of one-sided limit equal to 2, we can conclude that lim f(x) x approaches 1 equal to 2. Next, infinite limit. When we say that the limit of f(x) approach infinity, it means that as x get closer to some value, let's say a, the function values increase without bound. So move to the question. When we try to evaluate this equation, as x approach 0 from the positive side, we can conclude that it was positive. What is a vertical asymptote? A vertical asymptote occurs where the function approaches infinity, either positive or negative, as it gets close to a certain x value. If both sides approach positive infinity, you have a positive vertical asymptote. If one side approaches positive infinity and the other side approaches negative infinity, there's a sign change indicating the different behaviors on the either side of the asymptote.
Okay, for example 1, which is find limits x approaches 1, x squared minus 6x plus 5 over x minus 1. Okay, first of all, we must substitute the value of x, which is 1, into the equation. If we get 0 over 0, then we must evaluate the limit using factorization or multiplication with conjugate. But to using multiplication with conjugate, we must use when the question involving a set. Okay, so for this example, first of all, we must substitute the value of x, which is 1, into the equation. So it will be 1 squared minus 6 times 1 plus 5 over 1 minus 1. So equal to 0 over 0. So for this question, we can evaluate the limit using factorization. Okay, so let factors x squared minus 6x plus 5. Factoring means we want something like x plus or minus blank and x plus or minus blank. What number is the blank? Okay, so we see that a and b need to be two numbers that multiply together to get 5 and add together to get negative 6. So to get number 5, we can multiply together. 1 times 5 is 5. Okay, let's go back and fill in the blank with x minus 1 times x minus 5. Okay, let's check the answer using multiply the answer we get. Okay, x times x, it will be x squared. X times negative 5, it will be negative 5x. Negative 1 times x, negative x. And negative 1 times negative 5, it will be 5. So it will be x squared minus 6x plus 5, same with our equation. Then our factorization is correct. So let's continue to our question, which is limit x approaches 1. So x minus 1 times x minus 5 over x minus 1. So we can cut the same number, x minus 1. So it will become limit x approaches 1, x minus 5. Then we substitute the value of x. So the answer, it will be 1 minus 5 equal to negative 4. So the answer is negative 4.
Example 2. Find limit as approaches 2 from the right for this function. This function have a modulus. So first we need to simplify our modulus in piecewise function that have positive function 2 minus x greater or equal to 0 and negative function negative 2 minus x smaller to 0. 2 minus x greater or equal to 0. We can solve 2 transfer become x negative greater or equal to negative 2. Domain divide by negative, so we need to change the sign become less or equal. Do the same calculation for negative 2 minus x. So we make a new function 2 minus x less or equal to 2 and minus 2 minus x greater to 2. We do the number line 2 in the center and we write the function based on the sign. So as we can see, we will take the right function that negative 2 minus x. Write the new limit like this. But when we substitute 2 directly, the result is 0 over 0. It does not exist. So we need to factorize. So we factorize that divide the same as negative 2, then substitute 2 in the function. So the final answer we will get is 14.
For example 3, we are given the graph of function f(x) and we need to determine 4 things at specific points A, which is the value of fa, the left limit, the right limit, and the overall limit. If any of these limit does not exist, we will explain why by looking at the graph behavior. We will go through each point step by step. First, when a equal to negative 2, from the graph, f negative 2 equal to negative 1 because the closed dot at y equal to negative 1. As x approaches negative 2 from the left, the graph oscillates and does not approach a single value. So, limit x approaches negative 2 from the left of fx does not exist. As x approaches negative 2 from the right, the graph approaches negative 1. So, limit x approaches negative 2 from the right of fx equal to negative 1. Since the left and right limit are not the same, limit as x approaches negative 2 of fx does not exist. Next, for point A equal to 1, from the graph, f1 equal to 4 because the closed dot at y equal to 4. As x approaches 1 from the left and right of the graph approaches the same value, which is 3, so the overall limit when x approaches 1 of fx is 3. For point A equal to 3, from the graph, f3 is equal to negative 2 because the closed dot at y equal to negative 2. As x approaches 3 from the left, the graph approaches 1, so limit x approaches 3 from the left of fx equal to 1. As x approaches 3 from the right, the graph approaches negative 3. So, limit x approaches 3 from the right of fx equal to negative 3. Since the left limit is not equal to the right limit as x approaches 3 of fx does not exist. Last, when a equal to 5 from the graph, f5 equal to 4. As x approaches 5 from the left and the right graph approach the same value, which is 4, the left limit is equal to the right limit, so the overall limit when x approaches 5 of fx is 4.